how to draw the energy level diagrams for different molecules. So this is a pictorial view of energy level diagram. At the base, the minimum energy orbitals are there, and as we go up, the energy go on increasing. So there are different standard steps for filling the molecular orbitals. The first standard step is the molecular orbital with lowest energy is filled first. Thus, sigma 1s is filled first, whereas sigma star 2px is filled in the last. And the order goes in like this: sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s, sigma 2px, pi 2py, and pi 2pz. They are of equal energy. Pi star 2py, pi star 2pz, they are also of equal energy, and sigma star 2px is of the highest energy and is filled at the last. And the second step, the maximum number of electrons a molecular orbital can hold is only 2, and that too with the opposite spin. That means, for example, in sigma 1s, the maximum number of electron is 2, that too with the opposite spin, plus half and minus half. The third step, if there are two molecular orbitals as with the same energy levels, electron will occupy separate orbitals leading to unpaired electron spins. That means, for example, pi 2py and pi 2pz have equal energy. If there are two electrons, both 2py and 2pz orbital occupy one electron leading to unpaired electron spins. From this energy level diagram, we can find out the bond order of a molecule. The formula goes like this: the bond order is equal to 1/2 of the difference between the number of electrons in the bonding molecular orbitals and the number of electrons in antibonding molecular orbitals. So how to find the bonding and antibonding molecular orbitals? It's a simple trick. The bonding molecular orbitals are sigma 1s, sigma 2s, sigma 2px, pi 2py, and so on. And the antibonding molecular orbitals are sigma star 1s, sigma star 2s, pi star 2py, and so on. So remember this: if there is a star, then it's an antibonding molecular orbital. If there is no star, then it's a bonding molecular orbital. So this is the theory you have to remember about the energy level diagram. So now we shall take one example and show you how to draw the energy level diagram and explain about the properties. So now we are taking O2 molecule, oxygen molecule, as an example. O2 molecule have 16 electrons, and there are two oxygen atoms each having 8 electrons, and the electronic configuration goes like this: 1s2, 2s2, 2px2, 2py1, and 2pz1. Now draw the energy level diagram. We have right side boxes and left side boxes for atomic orbitals, and the middle one is for molecular orbitals. We have two oxygen atoms. One oxygen occupies the right side boxes and the other occupies the left side boxes. Now go on filling the electrons in the atomic orbitals. So in 1s you can add 2 electrons, in the 2s you can add 2 electrons, total 4, and the remaining is 4. So you have to add these 4 electrons in the 2p orbital: 2px1, 2py1, 2pz1, and the remaining one goes for the 2px, and same is happened in the both sides of the atomic orbitals. Now it's time to fill the molecular orbitals, that is sigma 1s and sigma star 1s, the lowest energy orbitals. And we have 4 electrons in the atomic orbitals, and we have 2 molecular orbitals. So we want 4 electrons, and we have 4 electrons, and fill them with no doubts. Now we have to fill the next molecular orbitals, that is sigma 2s and sigma star 2s. We have 4 electrons from the atomic orbitals, and we want 4 electrons for the molecular orbitals, and that balances out. Remember always how many electrons we have to fill in the molecular orbitals. In this example, O2 has 16 electrons. Now we have filled total of 8 electrons in the molecular orbitals, that is 4 in the sigma 1s and sigma star 1s, and 4 in sigma 2s and sigma star 2s. So remaining 8 electrons we have to fill in the 2p orbital. As I have told, we have 8 electrons. So go on filling from the lowest energy. So the lowest energy according to the order which I have given in the first standard method is sigma 2p x. So sigma 2px can hold 2 electrons, remaining is 6 electrons. And the next comes pi 2py and pi 2pz of equal energy. So we have to, the vacancy is 4 electrons and we have 6. So add the 4 electrons, and the 2 electrons goes to the antibonding molecular orbital. So the next orbital according to the energy level is pi star 2py and pi star 2pz of equal energy, and we have 2 electrons. As I have told you before in the standard methods, you can't add both the electrons for the same molecular orbitals. So the electrons goes to both of the molecular orbital, that is 1 electron for pi star 2py and the 1 electron for pi star 2pz, forming unpaired electron molecular orbital. Now we have to write the electronic configuration for the molecular orbital of O2 according to the energy level, and it goes like this: sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py1 and pi star 2pz1. Find the bond order from the given formula. Half into number of electrons in bonding molecular orbitals minus number of electrons in antibonding molecular orbitals. So we have 10 electrons in the bonding molecular orbitals, that is 2 in sigma 1s, 2 in sigma 2s, and 6 electrons in sigma 2px, pi 2py and pi 2pz, and we have 6 electrons in antibonding molecular orbitals. So the bond order is 2, and therefore O2 are bonded by double bond. We can also find the magnetic properties of a given molecule. If we have unpaired electrons, it is paramagnetic, and if we don't have unpaired electrons in the molecular orbital, then it's a diamagnetic. We have 2 unpaired electrons in this example, that is on pi star 2py and pi star 2pz, forming the magnetic property as paramagnetic. So if you understood the standard methods or steps, you can write the energy level diagram for any of the molecule you choose. And if you like this video, please do like, comment, share with your friends and subscribe to my channel. Sign or let's transfer. Signing off.